All right, so rational numbers from elementary school are just fractions. Okay, so the top number, bottom number are numbers. And as long as the bottom number is not 0, then you can turn it into a fraction, okay, which is called a rational number. We have what are called excluded values. So excluded values come in from the denominator. Whatever number would make the denominator 0. And that's because we're not allowed to divide by 0. And so what we do is we find these excluded values that would make the denominator 0. And then we can simplify the fraction after we do that. All right, so to find an excluded value, we factor, okay, our denominators if they're not factored, and then we set the denominators equal to 0 and solve it. So all this deals with is basically the same thing as what we did with the polynomials in Unit 3. We factor, and then we solve it. So on number 1, to state the excluded values for this fraction, we're trying to find out what would make the denominator 0. Well, the denominator is already factored for us, so now you just set each denominator factor equal to 0, and you would solve it. All right, so if we take x minus 2 and set it equal to 0, we would add 2 over, and so we get x equals 2. Hello.
That's correct.
Yes. Are you?
Can we interrupt for a minute?
Sure.
First, 30 seconds.
All right. So if we set x minus 2 equals 0 and solve it, we'd add 2 over, so x equals 2. If we set x plus 3 equal to 0 and solve it, we'd subtract 3 over, x equals negative 3. So these are the two values that would make the denominator 0, and we call those excluded values. So you can see it real easy. If I take, let's say, 2, and I plug it in for x here and here. This, when I plug 2 here, 2 minus 2 is 0. And then 2 plus 3 is 5, and 0 times 5 would get us 0 in the denominator, and you can't divide by 0. Right? The same thing would work for negative 3. If I put negative 3 here and here, this would be 0 times negative 5, and that should still give me 0 in the denominator. We can't divide by 0. So these are the two values that would make this fraction have a denominator. So we call those excluded values. All right, number 2. So it's already factored for us. So here we set 4x equals 0 and x plus 5 equals 0 because those are the factors that have variables. And if we solve those, okay, we would get x equals 0 for the 4x equals 0, divide by 4. And the x plus 5 equals 0, we would subtract 5 over, and we get x equals negative 5. All right, so hopefully you should see how familiar this is from the polynomials unit. Just factoring and solving. All right, number 3, what would the excluded value be? 0, right, because if you said x squared equals 0 and solve it, you would square root both sides, and you still get 0. All right, so that's how you find excluded values. Now, simplifying. So we want to remember a couple terms. Okay, these are algebra terms. Monomial, what a monomial is. A monomial is a single term made up of a number, could have a variable, could have exponents, could have multiple variables, could have multiple exponents. But it's just one single term. Right? So for example, 5 is a monomial term, or 8x squared is a monomial. 10xy cubed is a monomial term. One single term. Okay? Now, binomial is two monomial terms added or subtracted together. Right? So 2x plus 5 is a binomial. 4 minus 4 is a binomial. Okay. Two terms, two monomial terms, separated by an addition or subtraction sign. Now, when we're simplifying, we can only simplify monomial terms with monomial terms. And you can simplify binomial terms with binomials. You can't simplify a monomial with a binomial, or a binomial with a monomial, or a trinomial with a binomial. Okay, it has to be monomial with monomial. So, for example, 3x to the 5th and 12x squared, these are both monomial terms, so we can simplify this. All right? And so we would just simplify it like we would normally. 3 over 12 can simplify because we can divide top and bottom by 3. So the 3 would turn into a 1, and the 12 would turn into a 4. And then with the exponents, as long as the variables are the same, we can subtract exponents. That's back from like unit 0, I think. So we can subtract the exponents. So the 2 can go up, and it becomes x to the 3rd on top. So we get 1x to the third over 4. All right, so remember subtracting exponents. All right, now with binomial terms, okay, you can cancel like binomial terms with like binomials. They have to be exactly the same, like exactly the same, or you can't cancel them out at all. Okay, it's either all or nothing. So this x plus 3 can cancel with this x plus 3 because they're exactly the same. But the x minus 6 and x plus 6 cannot be touched because they're not exactly the same, so you have to leave them. So if they're not exactly the same, you cannot cancel it out. All right, so the x plus 3's would cancel, and I have x minus 6 on top over x plus 6 on the bottom. And that's simplified as far as you could go on this. All right, so you can't cancel the 6's and the x's. It doesn't work that way. And that's because they're binomial terms now. All right, so now let's go ahead and state the excluded values, and then we're going to simplify. All right, so again, first step is always check to see if it's factored. The top has to be factored, the bottom has to be factored. Everything has to be factored. All the rules of factoring come back. Look how many terms you have. Do you have 2 terms, or 3 terms, or 4 terms? Okay, all that stuff comes back. So this first one is already factored for you. Everything's factored. Can't go any further. So now we want to state the excluded values. All right, so we take the denominator, wherever there's an x, set it equal to 0 and solve it. Okay, so for 4x, if you set it equal to 0, you get x equals 0. For the x plus 6, if you set it equal to 0 and solve it, you're going to get x equals negative 6. So you can see it's just the opposite sign when you have binomials. So the excluded values are 0 and negative 6. Now we want to go ahead and simplify. So we always do this excluded value stuff before we start canceling things out. It's always your first step. You factor first, then you find your excluded values. Now you go ahead and start simplifying. All right, so monomial terms can cancel with monomials. Binomials can simplify with binomials. Okay, so here we have a monomial term 10x to the fifth and another monomial term on the bottom for x. Those can simplify because they're both monomial terms. Okay, I have a binomial x plus 6 and another binomial exactly the same x plus 6. Those can cancel, okay, because they're exactly the same. All right, now the 10 over 4 I can divide by 2 on top and bottom. That turns to a 5 over 2. The x to the fifth over x can simplify because I can subtract the exponent. So the x on the bottom goes away, and that 5 exponent turns to a 4, because 5 minus 1 is 4. All right, and then that's about as far as you can go. Now you just got to see where your answer is in there. Okay, kind of clean it up a little bit. So it looks like on top is 5x to the fourth. And on the bottom, it's just 2. Right? So this is why it's important to get your excluded values before you start canceling, because if you look at your final answer, you'll never get those excluded values from this. Okay, they're not there anymore. So that's why you get it before you cancel, then you can win. All right, number 5. What's the excluded values? Good, plus or minus 2. Okay, or you can list them out as separate, or you can use a symbol, either one. All right, now we want to simplify. I have an x minus 2 on top and bottom I can cancel. Now, because everything canceled off top, I have to leave something on top. I have to leave a 1. And so that's as far as you can go with this, so 1 over x plus 2. I would get in the habit of using parentheses around the binomials. It's going to save you from trying to cancel things out that are not allowed to cancel. So if you see it as a binomial, a whole term, hopefully that saves you. All right, number 6. What are the excluded values? 0 and 5, good. All right, now we want to simplify. I have a monomial term, negative 4x cubed, and then another monomial term, 2x. I can simplify that. The binomials cannot simplify because they're not exactly the same. One has a plus, one has a minus, so you're not going to be able to touch those. All right, so let's see. The monomial terms, I can divide top and bottom by 2, so that's going to turn to a negative 2 over 1. Okay, the x's, again, I can subtract exponents, so that x on the bottom will cancel with one of the x's on top and make that x squared. All right, and that looks like about it. So now I write my final answer, negative 2x squared parentheses x plus 5 over x minus 5. All right, we're not going to distribute and multiply back in. Okay, so don't distribute this back in. We want to leave our answers factored in factored form. All right, now 7, we have a trinomial on top and a binomial, and we have to factor. All right, you have to factor first. You can't go, well, you know what, I want to cancel these 2's out, okay, because they look like they actually just cancel. You can't do that. You cannot cancel part of a trinomial and part of a binomial. It's all or nothing. You can only do it all if they're exactly the same. All right, so we're going to factor. We have 3 terms, so we use the x method for factoring on top. On the bottom, there's 2 terms, but it looks like there's a GCF, greatest common factor, that can count. All right, so using the x for the top, 2 on top, negative 3 on the bottom, 2 numbers that multiply to 2 but add to negative 3. Negative 2, negative 1. All right. So on top, I have x minus 2, x minus 1. All right, now on the bottom, I'm going to pull a GCF out 2, and I'm left with x squared minus 1. Now, x squared minus 1 is a difference of squares, so that's going to go further. I can factor that into 2 more binomials. Okay, so just cross it out and write the new factors, x plus 1, x minus 1. Right. So, in factor form, everything's factored out, x minus 2, x minus 1 over 2 times x plus 1, x minus 1. This is everything's factored out. All right, what are the excluded values? Negative 1 and positive 1. Okay, the 2 in front doesn't have an excluded value because there's no variable with it. Okay, there's no variable, so we can ignore that for excluded values though. If there was a 2x there, then yes, we would get 0 as an excluded value. All right, so just negative 1 from here, positive 1 from here. Now we want to simplify. All right, so x minus 1 on top can cancel with the x minus 1 on the bottom, and that's it. So x minus 2 on top over 2 times x plus 1 on the bottom. All right, number 8, you have a trinomial on top, a binomial on the bottom. We have to factor. Okay, so again, use the x. Look for GCF. All right, so on top, negative 14 and 5, 7 and negative 2. All right, so on top, it'll factor into x plus 7, x minus 2. On the bottom, I'm going to pull a GCF out, which is 3. I'm left with x squared minus 4. All right, now x squared minus 4 is a difference of squares, so that'll factor further into 2 more binomials. Get rid of that, x squared minus 4, put x plus 2, x minus 2 there instead. All right, so now everything's factored. So what would the excluded values be? Negative 2 and positive 2. All right, now I want to simplify. I have an x minus 2 on top and bottom. I can cancel those out. And that looks like it. So x plus 7 on top over 3 times x plus 2 on the bottom. All right, number 9, you have a trinomial on top, trinomial on the bottom, so you got to factor both of them using the x. Okay, I know some of you guys, especially those that aren't really doing a whole lot of the homework, okay, when it comes to time for the test or quiz, you know, you'll see this and people go, oh, it's 3 and the 12, I can cancel that out. And then, oh, I have a 7x and a 7x, I can cancel that out. Okay, that tells me you aren't doing homework. So it's really common for people to do that. You got to save yourself from doing that. You got to make sure you pass it. All right, so the top one, multiply 2 and 3, that's 6 on top, 7 on the bottom. Two numbers that multiply 6 add to 7, 6 and 1. We're leading off with a 2, so we have to divide both by 2. 6 over 2 is 3. All right, so the factors on top become x plus 3, and then 2x plus 1. Okay, on the bottom, we have a trinomial, so we use the x on that. 12 on top, 7 on the bottom. Is that 4 and 3? So x plus 4x plus 3. All right, it's factored all the way. Our excluded values, -4 and -3. Now we simplify, and you cancel x plus 3's out. So the final answer, 2x plus 1 over x plus 4. All right, so go ahead and do number 10. You have a trinomial on top, so factor it using the x. A binomial on the bottom, but there's a GCF that can come out. Okay, always look for those GCFs that can come out. And then look for difference of squares. Okay, those come up a lot, difference of squares. All right, so we have our factors. Okay, now we have to set the denominators equal to 0. Every place there's an x gives an excluded value. So there's one here, here, and here. So there's 3 of them. So 0, -2, and +2. Now we cancel. X plus 2 can cancel with the x plus 2. And that looks like it. So x plus 18 on top, x times x minus 2 on the bottom. Right. Again, this is really important. Make sure you factor everything. Top and bottom have to be factored all the way through.